Hello once again, my fellow programmers. I hope you're all feeling great. And welcome back once more to this animated PLC course. So let's analyze in this class very simple topics, but very important topics. So we're going to analyze our automatic component system. And if you guys don't know much about this, I recommend you guys uh, don't speed up this video. Okay? Now, automatic system. We analyzed previously how the human works and how the machine works. So now we're going to, uh, you know, turn to look at it in detail. Now this is a device, and what's it doing? It's getting a signal. And where's that signal coming from? In this case, an operator, an operating system. It's getting the startup signal. It's on hold for someone to press the green button. Or if the system is already working, it's on hold for someone to press the red button to stop. So then the situation is as such. We have the device waiting for it to get the signal. And once it gets the signal, it's going to transmit that information, whether it's through a communication cable, in this case Ethernet or RIO communication, whether we're working with Siemens or Profinet, or through, I don't know, how am I going to get that signal from my device to our PLC or through an electrical device? How am I going to decide? In this case, let's suppose that it's connected through an electrical signal, a cable that has continuity, and it's going to either send a voltage or not send a voltage. If I send a voltage, let's suppose that the machine is stopped, and all it has to do is start up a motor. So with the button, it gets the signal, or in this case, our PLC, which is our pet for our PLC, which is an embedded PLC. It has its device, its inputs and outputs already embedded. Okay, so now we're going to look at the differences further down. But if any of you have any experience on this, I'm not going to skip that. I know that's important, but not for now. Okay, I want that either a robust PLC, we look at it as a PLC, and then we're going to make sense of things. So the PLC gets this, right? And now what do we want to do? We had also said that the PLC would send the orders. That was in charge. That is what's in charge of sending the devices, which in this case we need to control. Now, I told you at the beginning of the course, we're going to control processes, okay? That's why it's important to identify this circle. Because what's it going to control? A motor. That's how, depending on the variables that we're going to use, we're going to continue controlling our electronic devices, which are specifically designed to control whatever variable. So far, make sense? Perfect, because we're going to get a lot more devices. So this button is only our contact or our drive or just a button itself. And we're going to connect a motor. And we're going to explain this in bigger detail. I'm going to explain our relays and everything. Okay? So, as devices that can get signals, we have these devices that I'm showing on our left side of our slide. We have, for those of you who don't know this is an encoder. The encoder is coupled directly to our shaft. And this, depending on how many spins, we are able to know either the velocity or the position. Generally, these are the variables that we need to know about, especially in industrial robotics or in stop motion, which is for industrial programming. So this ultimately is what's indicating us what our position is. And depending on this position is where I'm going to send my servo to move. Okay? So inductive sensors, capacitating sensors, photoelectric sensors, which are, so to speak, a ray of light, okay, that goes through an object goes through, and it says, hey, something is going through my ray of light. And we send it to our PLC, and depending where it goes from there, we can activate a valve or a piston, or I simply indicate that that product is wrong, or that ray of light helps me identify that there's an object, okay, from here to wherever I program this, to object 100, let's say. And that gives me a packaging of whatever it is, nails or whatever. But it starts making sense, right? Now, in our control part, here on our left side is the reception, and on the right side is the control part. So we add here a division for devices that are in charge of getting information and devices that have the function or are in charge of running animations and to move and control variables. For example, on the top side, oh, I'm actually right here. Let's move a little bit on this side. So we have this, we have a servo motor. Small, but powerful still. Okay? These aren't the same servo motors that we find in college or at the university. Okay? These are the ones where we thought that we were experts because it moved 180 degrees. Okay, those are regionals. The major leagues are these, even though it's a little one, a small one. If it moves 30 Newton meters, because related to torque, it has a lot of strength. So here it's controlling with our finger for our shaft, and it has a lot of torque, and even though it's very small. So this is for processes where they need to move big loads or move to an impressive speed. And this is controlled through a servo drive. Okay, so this course is to learn how to reprogram in scale for PLC. But we can complement this even more because we can fundamentalize talking about specificities. And also for our PLC, we have our specialties. We have Allen Bradley, Siemens, and we're uploading new content every month. So if you wish to specialize on a specific brand or really specialize in drives or servos or industrial networking, we have it all. So in the end, it is a control device. Lamps, traffic lights. If I'm sending or if I'm lighting a light bulb, that's a control, and I'm controlling that device. The PLC is controlling that device. Okay, so a pump on the bottom part, we have our piston. Okay, and what characteristic does all this have? On this side, well, this that looks like fireworks or firecrackers, that's not what they are. These are coils. These coils have are transmitted voltage to. And with that voltage, we start getting, they start getting heat automatically through the resistance. But every coil has different qualities, remember? These can get to certain temperature, or in the case now for readings, this is a thermocoupling. And remember that these are used to measure temperature. This is measurement. So this right here is a relay. Now, this relay, its core function is to transmit voltage more securely. And this is where we control our uh, light bulbs. Our lamps are connected to the relays so that they can control more efficiently our automatic system. Now, I also don't want to get too deep in this topic because I don't want to confuse you guys. But these are devices that are very commonly used in the industry. And there's still more that are that we've not talked about. Fluxometers, uh, pressure meters, okay? And then after this presentation, we're going to start leaving our exercises. And I'd like you guys to solve this. It's an interactive drill. If it's still, if it's not there after this course, don't worry, guys. You're days away until you see the exams and the tests. Okay? So this is so that you guys can keep all your learnings. So practice makes perfect, as I say. The more we practice, the more knowledge we're going to get. And it's no use that you guys see me only if you guys can't keep the concepts. So we're going to reaffirm this through our interactive course. So we need to identify what variable matches each device, whether it's a the receptive device, which is always getting signal, or the device that is always controlling. And then I'm going to get interactively what it matches. Okay? Now, for all these guys, for all the reception devices to control, etc., because if we separate them in an orderly fashion, we're going to add names to it. So the signal receptor devices are known as input devices, okay, or our very famous inputs. Our controlled devices are the same as outputs. Every device that is able to modify the variables for certain processes are outputs. So we need to learn how to identify them. Okay? Now, in summary, let me adjust it here on the bottom part. First off, the input devices get signals, and that is cause. Depending on what we're getting, they're going to run with certain consequences. So the PLC obviously also gets this device and that data for these measurements, for these devices. Okay? And then from what we had programmed, our PLC is going to assign orders to the output devices. So I can't send out an order because its sensor is not their task to do something, but to receive a signal. But they can't do anything about that. So that's why we also have our Animator PLC concept. If you notice, our exercise is process, and we need to animate them. So what we're seeing in these slides are, for example, the lights that's powering on, the motor that's in motion, the electro valve, which is connected to the pneumatic piston, or a piston for what we want to uh, handle. But we also need an electro valve. Now, relays, but these are always powering on. They're always activating. So that's why it's all about consequence or effect or action. So the outputs are always going to be in motion. They're always going to show something. If something sounds or makes a sound, it's an alarm. So they're constantly in motion. So PLC gives orders to our output devices, and our devices uh, get the orders, and our devices act on it. So on the top part, we have our input devices. And on the bottom part, we have our output devices. But they very well may be connected through a cable, or an Ethernet cable, which, let's say, for example, are connected through communication. And they can talk between them, PLC 1 and PLC 2. And the instructions, who runs them? We do, programmers. Through what? Through a software. In this case, an Animator PLC. We assign the logic, we bring out the instruction, and we leave our conditions where if sensor 1 is being detected, then it activates the output, which is X or whatever. And then we're going to find more logic to things. Okay? Did you guys like this class? I liked it very much. Now we're going to go to our next class, which we're going to talk about our components for our PLC components. These are the components for an automatic system. And we're going to go in to our components for PLC. Thank you very much, guys, for your support and your time. And I'll see you on our next lesson. Big hug, guys.